My name is Nestenius. I'm from Sweden, and I'm happy to do a talk here with the the Tulsa.net user group. And so what I'm doing so my day job is I'm a freelance trainer, instructor, and coach, creating training material, teaching developers at companies all around the world. I do blog frequently on my blog at nestenius.se, and my focus area is authentication, OpenID Connect, .NET, and also some Azure. And I'm also the co-organizer of the .NET Skåne, so that's a local Swedish meetup. So if you ever come to Sweden, and you want to kind of meet up with local .NET developers, then feel free to join our meetup. As I said, I'm an instructor, so I do teach everything from fundamental.NET up to advanced async.NET. I do teach about Azure, web security, a lot about OpenID Connect and software architecture. And I've been teaching developers for about 14 years by now. So to the content. It's really also important, as Sean said before, that if you have any questions, feel free to ask in the chat, or do feel free to interrupt me as well. I really like to have the discussions with you. So what's the goal of this presentation? So the goal is to talk about, if we create a web application, we all want to get the kind of a signed-in experience. You as a user, you can see your name, you can log out from the application. That is a goal. But how do we get there? And let's try to explore the pipeline and steps we take to get to this place that we can be signed into our application. And so we're going to demystify the plumbing and infrastructure behind the scene that makes all of this possible. But I think the first question is, how do we get this information? How do we get that information into a page, and where's the data come from? So to populate the page with your credentials and information, and to know if you're actually authenticated, we have a ClaimsPrincipal object. So somehow we pass a ClaimsPrincipal object to the page, so the page can display my name, for example. But the question is now, of course, what is a ClaimsPrincipal? So internally, a ClaimsPrincipal object, I think the name is a bit weird, but we have to kind of stick with it. It's actually a collection of identities, and in fact, something called claims identities. So a ClaimsPrincipal is just a container of a set of identities, usually one, but you could add more in some special cases. And inside the claims identity, we have a set of claims. And the question is, what is a claim? Well, the claims are the facts about you as a user, or facts about how you authenticated, or facts about your roles and what you want maybe to have access to. So claims in OpenID Connect and Authentication is just a set of key value pairs, a name and a value. Like in this example, you have your subject, you have a name, an email, and a role. They are all claims that we then can display on the page or use when we do authorization. So then the question is, who creates the ClaimsPrincipal object for us? Someone has to do it. So to understand that, we need to look under the hood of ASP.NET Core. So under the hood, we have a request pipeline. So that means that when a request comes into the application, Kestrel, our web server that we have here, that one will take the incoming HTTP request, inspect it, and then create a corresponding HTTP context object. And then internally, we have a big pipeline here of middlewares, modules that we can add to this pipeline that will do various things, inspecting the request, manipulating it, and then also look at the response, and for example, do compression, or can be, security, or could be logging or error handling, whatever you like. But in our case, a request comes in, we get an HTTP context object, and that one passes through these kind of middlewares, and then finally it ends up at the MVC middleware, and that one can take the information in the context object, and that object represents my request, and then it can display the page for me. And then it renders the page, and then it puts the page into the context, and then it goes back through the pipeline, back to Kestrel, our web server, and then it can be translated back into a HTTP response. So that's the kind of the fundamental internals of ASP.NET Core in general. But in our case, the one that sets the claims principal object is the authentication middleware. So there's a special kind of middleware module that we add to this request pipeline that is in charge of creating this claims principal object. So what happens is when the request comes in here from the left, we are in fact anonymous. We don't know who is the user. So it is the job of the authentication middleware to try to identify who is the user and populate the HTTP context object with this claims principal object. And it will contain the claims about you as a user. And then the page can use this object to kind of display various facts about the user. Okay, so we have this middleware. So, and the data typically, okay, so the authentication middleware typically gets its data or your kind of credentials from a session cookie. That's the most common case. But it could also be access tokens, it could be certificates, or some other kind of ways. But typically for us, we use the session cookie. That is the information we need to establish who is the user and create this claims principal object. So in my case, I do have a sample application here. I will demonstrate it first, and then I will kind of add this middleware to the application. So in this case, I do have a plain, simple MVC application. I will just do a restart here. And I will kind of show it to you. It's a classic MVC Hello World. I do have a secure page, but this one does not really work at the moment. There's no authentication. I do have a login kind of form, but it does not work either. So we're going to fix this and applying the authentication steps, step by step, to make sure that we can sign in and sign out from this application. But in our case, we want first to add the authentication middleware. So we can add it to our program class. So we add it here, add authentication. And then also we go down and add the kind of use authentication down here. So this one adds the authentication middleware to the request pipeline. The framework will in some cases add it for us, but I think it's really good to be explicit to have it, included in my code. But just adding that will not make any difference. So even though I will start it and I try to kind of do something, nothing will happen. So it's kind of just a kind of a starting point. We need the authentication middleware. But that's not enough. We need to do more than that. So we need to look inside the authentication middleware, what is inside it. So inside it, we have a set of authentication handlers. We can have a cookie handler, for example, in some cases. And if you have used .NET, you might have seen this kind of code construct. You might have you might have the JWT bearer handler for APIs, or you might have two handlers when you use OpenID Connect in a client application. So inside the authentication middleware, you add those authentication handlers to do various things for you. And we will be working with a cookie handler in this presentation. So in our case, we will add the cookie handler to my application, and I will set in the login path and logout path, and also access denied path. I will come to those a bit later. So I'll go back to my application here and just copy the code, nothing special. So now we add the authentication middleware, and we add the cookie handler into the authentication middleware. And we have set some configurations, but still there's nothing much that will happen in our application. So there's no point in kind of demonstrating anything at the moment, but we'll come to that. So, okay, we have that in place, that's good, but we need to understand the operations that we can do on the authentication middleware. So the authentication middleware supports 5 different methods. We have authenticate, and we have a sign in, we have a sign out, forbid, and challenge. Those are the 5 core operations that we can send to the authentication middleware and then indirectly to our cookie handler. So what do they do? Well, the authenticate one takes and looks at the incoming request. It will, pass the details to the cookie handler and try to look at the cookie that is kind of is part of the request. Try to see, can we create an identity based on that information? And if so, we create this ClaimsPrincipal object. So this one is actually the one and only that creates the ClaimsPrincipal object we saw before to be displayed on the screen or used in authorization or for other purposes. The sign-in is all about remembering me. It's all about trying to create the authentication cookie. So you have signed in, and then you call the sign-in method to create the authentication cookie. And in the same way, you have a sign out. That's all about deleting your authentication cookie. You have a forbid, and that is all about, for example, if you make a request to your application, you are authenticated, but you're not allowed, you don't have the correct permissions, then your application, for example, can call the forbid operation, and that forbid operation will then, in most cases, do a redirect to your access denied page. And finally, the challenge, that one we call that when you get an incoming request, you don't have any idea about who is the user, you're anonymous, and then your application or your authorization middleware will ask you, please go and log in somewhere. And the challenge part basically is all about redirecting the user to the login page. So these are the core operations. And of course, if you do have any questions, feel free to write in the chat or just ask me as we go along. So in our case, we want to have this secure page. It's a really, really important page, and it's important that you are authenticated properly to access this page. So what we will do in this page is to check, the current claims principal. Do we have an are we authenticated? Are we not authenticated? We will call the challenge operation, asking the user to be redirected to the login page. So we add this to our kind of super secret page. It's currently just in an empty return view, but we will add this information here to ask the user to be challenged. So when we are challenged, we call the cookie handler, and the cookie handler we have defined here, and basically it will redirect the user to the login path as defined in your cookie configuration. So if we now were to run this application and we try to go to the secure page, we will see the following. I just need to move the browser here. So we'll go to the secure page. will be redirected, as we see here at the top, to be used on login page. All is good. We will fix the login form in a bit, but for now, it's pretty good. When we go to this secret secure page, we are challenged and the user is redirected to the login page. Okay, I hope that makes sense. So that's good. So let's look at the next part. We need to talk about schemes as well. So schemes is also an important thing when you want to configure your authentication middleware. So in many cases, you might have 2 or more authentication handlers, typically 2 or 1, but sometimes 2. And the challenge is when we have, for example, 2 handlers is if we, for example, do a challenge now to our authentication subsystem, we need to know or decide, or define who should handle it, because we only want one to handle my challenge in this example. I don't want to have both. So we need some way to do this mapping between those operations and who will do which one. And that's all up to you, how you want this configuration to be. So what we can do is to define a scheme. So we can give each of the authentication handlers a name, for example, cookie in this case, and now IDC for OpenID Connect. And then up here in the add authentication configuration, you define which handler will handle each operation. So in our case, if you're using OpenID Connect, for example, you typically want the challenge part to be handled by the OpenID Connect handler and the rest by the cookie handler. But it's all up to you how you want to configure it. So in our case, we will set the default scheme, and that means setting all of those 5 to be the cookie handler. So when we do any of those operations, we will always go to the cookie handler. In our case, we don't actually need to set it because we only have one, but just for clarity, I really think it's good to be explicit. So I will just copy this code in here. So we set this default scheme. Doesn't change anything in our application so far, but it's always good to be clear about who is doing what. And I see a question in the chat. Is there anything else challenge might do, or does it always redirect to a login page? So it's all about you might, in some case, maybe have something else in there. It does not need to be the cookie handler. It might be some other implementation. So this is pretty implementation independent. So you could have some other, if we go down here to the challenge part here, you might have some other handler that might do something totally different. So in our case, when we use a cookie handler, we are doing a redirect, but the challenge could be something else. It could be asking if you have some hardware tokens or smart cards, or if you use maybe Windows authentication or some other thing. So it's all depends on the implementation of the handler that you're adding. So it's not always a redirect, but for web applications, we typically use the cookie one, and that one will do a redirect. I hope that. So those names here, you can call them whatever you like. It could be like Donald Duck or whatever. It could be, but it's just a name. So is those names here and the cookie have no specific meaning. It's just a mapping between the name of the handler and the configuration at the top where we define who will do what tasks. So we're not going to cover OpenID Connect and OAuth here today. We could do that another time because that's a talk of itself, or maybe a day of itself, because it's a really big topic. But today we're not kind of going into deep with OpenID Connect. So we have added the default scheme, that is all good. So now we want to sign in the user. So we learned about the sign-in operation before. So basically, we want when you click on the login form, eventually you want to call the sign-in method on the cookie handler. and to kind of set the kind of cookie, and then that cookie can be used to display the name on the page and also give you access to the secure page. But how do we do the sign-in? Well, so far in my application, I do have a very simple login page. I do have a plain embassy ways of view form here with a username and password. I do have an outline for the login action methods. So I do have my current login method does not do that much today, but we will kind of fix this in a bit. So let's talk about that method. How do we do that sign in of a user? So we have those login method. So when you click on a login button, you end up on your login action method here with the form data coming in here. And that login model is just a plain simple data object with a username, password, and return URL. So it's very simple. So the first thing we need to do in this login page is, of course, look up the information in your database to validate your username and password. And if that match, you continue. And just to keep it simple, we assume we have done that and the user is all good. So next, what we do is we load up the user from a database, and then we create a list of claims. And those claims comes from your database, and those claims can be anything you like. It could be your name, it could be role, it could be email, it could be your kind of user ID, like your subject in this case. But you could put anything you like inside this list of claims. And the claims here basically is facts about you, about your identity, your title, name, description, email, whatever you like. So you have this list of claims. So what's next? So after that, you take those claims and you create a claims identity. We mentioned that in the beginning. That is basically your identity, and it contains your claims. You also include authentication type, and the type here it defines how did you authenticate, in what way. Was it like smart cards? Was it username password? Was it using certificates or Windows authentication? So because that can be important when you do authorization later on, to how did the user authenticate. So you always need to set the authentication type, and if you don't do that, it will not really work with authentication. So it's really important to set your type. When you have an identity, it's not enough. You have to have a claims principal as well. So we said before that the claims principal contains one or more identities. Typically, we only have one, but you might have two in some cases or more. So we have a principal. Great. So what do we do with a principal? Well, we can send it to the sign-in method. But first, there's a secondary data structure that we can add if we want to. It's optional, but it's always good to be aware of, and that is the authentication properties. That's a different kind of data collection of various information. You can specify the redirect UI, that after you have kind of signed in, where do you want to end up on? You can define custom kind of metadata about the authentication, like something you want to add to the user data, like some keys or like computer name or some other kind of facts that you want to be part of the user's authentication claims. So you take your claims principal and the authentication properties, and you pass them into the sign-in async method. And you can also specify here which handler do you want to sign in to. And we specify the cookie handler because that one is the one we want to use to handle the sign-in operation. So we pass in the principal and the properties to the cookie handler. That is what we're doing here. So in our application, we will copy this code to it, and then we will give it a try. And so we go in here and we just kind of replace this code here with, getting the claims, getting claims identity, claims principal, and authentication properties. And if we now were to run this application, we would actually be signed in. So I do try to log in here. We can enter anything, but we click the login button and we are signed in. And we can actually look here if we click on the name, hello Bob, we can actually see the different details about the user. So we have an identity, we did authenticate using a password. We are authenticated. The name is Bob. We have a set of claims that we know about the user, and also we see the authentication properties. And we see that these are the ones we added, but it also adds some other internal ones for when was this authentication cookie authenticated, or when was it issued, and also when does the cookie or the information in the cookie expires. So we can see all that information at the end that matches what we kind of had here in our claims and in our authentication properties. I will come to what the cookie contains in a short bit, Matt, so I will kind of cover that in a short bit. But so far, so good. We have created the authentication cookie, and if we want to, we can always go to the browser and we can look in the among the cookies here, and we have our authentication cookie. So that is good. But maybe first we need to ask ourselves, okay, what happens when we do sign in async? So internally, so we said that we have the claims principal that contains the facts about my user. We have the authentication properties that represents additional information about the user. So when we send those to the cookie handler, we will create a new thing. Oh no, another thing. So now we will create an authentication ticket. But then, of course, the question is, what is an authentication ticket? So the ticket is only a data structure that contains both your claims principal, your authentication properties, and also the scheme, the name of the handler that you will kind of sign into. So you create this ticket. Okay, that sounds good. It's just a wrapping object that contains those three things. And then you encrypt this ticket using some data encryption. And we'll talk more about encryption later on. And then you take the encrypted data, you put it in a cookie and send it back to the browser. And optionally, you can do a redirect to some other page where you want to end up on after you have signed in. So this is what happens inside the cookie handler. It's only those 4 steps. There's a few other small, bits and pieces, but this is the kind of high-level fundamental steps that is taken inside the cookie handler. But then, of course, just to answer Matt's question here, what's inside the cookie? So if we look at the cookie here, it's really, this is actually encrypted. It's not encoded. So this is actually, really strongly encrypted, this information that is in the cookie. But I think still the question is, what is inside it? So it is encrypted, but how can we then, but the question is, can we peek inside this encrypted cookie or do some way to get a better understanding what is inside this kind of long string? And yes, we can do that. We can actually replace the default encryption logic with my own super secret, super confidential, super encrypted approach. So we replace the default encryption with my data protector class instead. And this one is so really good that it takes your incoming plain text and just returns it. So basically, we do not do any encryption at all. So by adding that, and we can actually add it to the cookie handler, there's a property to do that. So let's do that and see what happens. So in my case, I will, let's see where mouse here. Yeah. What I will do is just go to my program class. I will just copy this, my super special encryption code. And I will also define it and add it to the cookie handler up here. So we want all our cookies to be protected by my data protector. So the question is, what happens when we do this? Okay, so we do a login. We are, as before, same, nothing different. And if I look at the cookies, we see that it's a big long string. That does not make any sense. What can I, do about this string? But this string now is base 64 encoded. So let's go and base 64 decode it. And I do have a handy website for doing that here. And if I decode it, we actually see this. So we are using some kind of, binary serialization inside the cookie. But we see that this cookie contains all the claims and authentication properties that we created before. So the cookie contains everything your entire ClaimsPrincipal object. And that is the key. And of course, it's normally encrypted using a strong encryption. But in our case, it's only base 64 encoded, stored in the cookie. But we can see in clear text what is inside it. And I think this is really key here to understand authentication. But this cookie contains everything about you. And that one is used then to create the ClaimsPrincipal. So there's no other kind of storage involved. All your personal information is stored inside this cookie. Does this make sense? Do you have any questions? I do see a question about the JOT tokens and Open Connect and identity, but it's a bit beyond the scope of today. But if you do have some Open Connect questions, we can address them afterwards. But do you have any questions on the cookie or the cookie content? Then just feel free to write them in chat or ask me. So this is interesting. We can actually look inside the cookie by adding this super simple protection logic. Next, I want to talk about sign out. So what we want to achieve is when we click on a logout button, we want to come to the logout action method. And here we do sign out. We want to call the sign out operation on the cookie handler. That makes all sense. And that's good. And basically, what it will do is removing the cookie from the browser. So by default, all the sign out will do is to delete the cookie and make a redirect. That's it. So in our case, let's add it to our application. We want to do a logout. So I will go to my application, I go to my user controller, and I go out here to logout, and I will just call sign out async. So let's see what happens when we restart my application. And so we log in as before. We can access the secure page. We can see details about the user. All is good. When I click log out, we can actually look at the browser here. So right now, when I navigate, we do have an authentication cookie. And when I do log out, we see that the authentication cookie is deleted. I can actually clear the other ones as well. But we see that we end up on a blank page. That is not really so user-friendly. And we go back to the code, we saw that logout path. So why did it not redirect to the logged out page? That's weird. So we need to fix this somehow. And what is going on here? So far we call the sign out async to the cookie handler. And in the cookie handler, we have provided the logout path. We want the user to be redirected to the logged out path. But in the response, if we look in Fiddler or in the browser, we will see that we get back a 200 OK. We clear the cookie, and we clear the cookie by setting the expire date to a date that has been in the past, typically 1970, but it could just be yesterday or whatever you like. So it deletes the cookie. So that is not good. So how can we fix this redirect thing? So, you Google, you go to Stack Overflow and you look around and you see you've been mentioned somewhere the return URL maybe. So let's try to add that one, it might be a useful thing to do. It might help. So we go to, I do have some view partial here. We can go to the logout here. So that when we click on logout, we can pass in where do I want to go to after redirect. Let's try that. We are kind of trying things now to see if we can get this to work. We want the logout to be, do a proper redirect. So we do a login again. We logged in, go log out. Okay, so we see the path up here, but we just added, but still, it does not redirect. That's odd. I mean, if we look at the code of the cookie handler, it really, looks like, obviously, if you look at the code, I want to log out to this page after logout, but it's not. There's a catch, of course. So what's the catch? So far we have, added a return URL to the link, and we do have a logout path, but we still don't get the redirect. We still just delete the cookie. So something is going on here. So the question is, what does logout path actually mean? And basically, what it does is that it will do, we need to change it to /user logout. So the key here is that this one must match that one. And if those two matches, so I mean, basically, if a logout path and this one matches, so basically we need to specify what is the URL to your logout action method, what's the path to your logout kind of action method. And if those matches, the path and this one and this one matches, then it will trust this information and take that information and do a proper redirect. So this is more like a security feature that we don't want to randomly redirect to anywhere on any page. We really want to only trust this return URL query string on this specific URL. And if we do that, we will get a proper sign out. So let's try that. So we change this one to log out. And this logout basically means that we point out the URL to this page where I do the sign out async. And if I do that, and if I do have a redirect in the query string, then that query string will be accepted. So we do a login again. When I click log out, we are logged out properly. We are end up on the logged out page. So this is really a kind of a brain teaser here to trying to understand why your redirect does not work, and what does this actually do? So this one is all about a security check. but we only trust this redirect return URL if we are on this URL that is defined by this property. And if so, we will get a proper redirect in the browser, and we also delete the cookie. So that's good to know. What else? Yes. So the question is this sign out. So we saw in our application when we logged in, we are signed out, the cookie is deleted, all is good. Or are we? And actually, we have a problem here. So the problem is that what happens if a hacker steals my cookie? So let's try that. So I log in here in Chrome. I log in, get my authentication cookie. I can add add my Firefox. I can go to the same site, and in Firefox, I'm of course not logged in. Okay, I'm logged in, so I log out, and I'm gonna hide my bookmarks. Okay, so I am on my site here, not logged in, and I'm logged in on my Chrome browser. But what I can do is actually copy this cookie to Firefox. So I can go to the Firefox, I can add a cookie. I paste in the cookie name. It's a bit small here, so I try to zoom out a bit. And I go back and I copy the cookie value, paste it into Firefox. I reload the page, and we see that both browsers are now logged in. So we are both kind of Bob in this case, because we have one set of cookies to each browser. So we have the same cookie in Firefox and Chrome, and the backend accepts the same cookie, so it's all good. But if I now go to Chrome and sign out, okay, I'm signed out in Chrome, but if in Firefox, I'm still logged in. So this login here and the logout, just deleting the cookie, is not good enough, because the value and data inside the cookie that I do have here in my browser, that one contains, as I saw before, all my ClaimsPrincipal credentials, all my information. So as long as someone is using this cookie and the data is not expired, the data inside the cookie is not expired, because we saw that when we look at the user information, inside the cookie there's actually an expire date. So it means that for about 2 weeks time now, the hacker can be me on this application, and the backend will happily trust this cookie. Even though I signed out from it in Chrome, the sign out only deletes the cookie. It does not invalidate it. So that is the key here that we need to be careful about, that that can be a security problem. And we do not have the time today to really address how to fix that. We could do another talk in the future about that. But if you want some hints about how to do that, I do have a blog post talking about the approach, how to do that. I paste the link in the chat. And basically, the basic idea, just to give you a highlight here. Okay, so my question, the anti-forgery cookie is just a way to protect the HTML forms. It has nothing to do with authentication at all. So it's not, is my video dead?
No, I see your mouse moving.
Okay. I mean, Eric, you said your video is dead, so always, yeah. So, okay. So you see, I hope you see my browser page here. So basically, what you can do to fix this cookie problem that my camera?
Yeah, your camera's dead, looks like, so there's no signal.
Oh, okay. Let's, I can change to another one, perhaps. Does that help? Oh, okay, so good. Okay, so the basic idea is that instead of just, so the basic idea is to add a session store to the cookie handler. And what does that do? So basically, you had a database in memory or in a SQL database already. So somewhere you want to store the authentication ticket somewhere else, not inside the cookie. So when we send in this authentication ticket to the cookie handler, we send it to some store, in memory or in the backend or somewhere, and we get an identity back, like a grid, and you place that grid inside the cookie. And by doing that, so when you do sign out using this approach, then you actually delete the data inside this store. So even though the hacker steals your cookie, when you sign out and you delete the entry in your database here, then you will be totally logged out. So that's really the way to go if you want to secure your sign out and securing your cookies. I hope that makes sense. So that's, I think that's really key to understand. So to summarize this part, we have authentication middleware. We can add the cookie handler to this authentication middleware, and that one will, handle those 5 operations for me. The authenticate, challenge, forbid, sign in and sign out. And when a HTTP context comes in, you pass it to the authenticate method, and that one will then try to create a ClaimsPrincipal object and add it to your context object. So there's a question about, the benefit of using cookies compared to JOTs. So JOTs are good, but they're not so useful for browsing the web. It's more for calling APIs, because cookies are automatically added on your outgoing request. That is, how it would be really, inconvenient in many cases to just use JOT tokens to keep track of your session. And also, the benefit of using cookies is that if you, for example, go to look at the cookies, we are, for example, we have here our cookies. And in our case, you can actually, if you want to make your authentication cookie HTTP only, that means that in this case, it's false, meaning that JavaScript can access your session authentication cookie. But if you were to set it to true, you can prevent JavaScript from accessing your cookies. So that means that if you have a cross-site scripting attack, you have a vulnerability in your web application, in your HTML or JavaScript, then your JavaScript or that evil JavaScript can't access your cookies. So cookies are a bit more, it's easy to store them securely and protect them from JavaScript. If you were to use JOTs in your browser, then you would need to involve JavaScript, and then it's game over if you're hacked. So the forbid typically redirects you to your kind of your access denied page. So that's the purpose of that forbid. And Eric, you asked about the cookie agreement. Well, you need to talk about essential cookies and non-essential cookies. It's a bit beyond the and yes, you need to display the consent display if you want to have tracking cookies. But if you need, necessary cookies like the authentication cookie or the forgery cookies, they're not used for tracking, and you need it to support the page, then it's okay to do without the cookie banner. The banner is all about when you need the tracking from Google Analytics or Facebook or similar. I want to do one short other thing before we wrap up the day, and that is to talk about the data protection. So ASP.NET Core issues and secures many things. I mean, the ASP.NET Core issues many sensitive information. We have an authentication cookie, we have an anti-forgery cookie, we have a session cookie, we have a state and nonce is valid when we use Open and Connect. So all of those data, all of this data is protected by the Data Protection API. So the Data Protection API is a very simple module, but it's part of ASP.NET Core. It's always there, but it's pretty kind of obscure in the background. So basically, it has two operations. It has a protect and unprotect. That means that when you want to protect something, you send your data to it, and also you have an encryption key to do this encryption. So you basically send your, for example, your cookie data to it, you protect it, and you get some, protected information that you can store in the cookie. And then on the way back, you can unprotect it using this key, and then you get the clear text. So this is how the authentication cookie works, out of the box. That's good. So I do have a simple demo to display. I do have a separate application for this data protection demo. So we'll start this one instead. Just kind of just going to close this one. I will start this one. Too many windows. So I start this one. So that one, I will restart it again. Let me see. No, okay. No way. I'm starting the wrong project. I will start that one. And of course, we are using Aspire because we want to be modern and cool. So we have this application here. We will talk back more about Aspire in a short bit. But basically, I do have a simple page. I can go to the protect data page here. I can encrypt like your Tulsa.net. I can take a given input. I can encrypt it. And then I get some encrypted data. And then I can decrypt it back and get back, the input. Awesome. So this is a very simple demo of the data protection API in action. Okay, so that's good. But if you go to production with your ASP.NET Core application, then you will eventually see some weird log statements, some errors in the log, like keys were not found in the key ring, cookie was not authenticated, unprotected ticket failed, or similar. So what is going on? So in my application, sample application here, I do have two instances of my application. I do have a YARP load balancer proxy that will take incoming request and then, doing a round robin between those two instances. And we can actually see that in action if I go back to my site. I can go to the kind of load balancer. So when I will load the page, I actually, I'm randomly jumping between, instance 1 and instance 2. So we have a good kind of setup in place. Okay, so that's good. But what can go wrong here? Well, a lot of things. For example, when we do a deployment, users might be logged out. Cookies are not recognized across instances. We might see the various key management issues. So there's a lot of problems, with the data protection when we go to production. So, for example, if I now were to go to my application here, so if I reload it, we jump between, instance 1 and 2. I'm on instance 1 now. I do a login. I have a very simple login page. Good, we are logged in. But if I now reload the page, actually I need to go back to this one. So I'm logged in on instance 1, but in instance 2, I'm not logged in. But I only have one set of cookies. I do have one authentication cookie here, it's the same cookie in the browser, but instance one does not, instance one accepts my cookie, but the instance two does not accept it. That's weird. I mean, so what is going on here? We need to kind of fix this problem. So by default, when an application, an ASP.NET Core application starts up for the first time on maybe a blank empty machine, it will create an encryption key. So each instance, in this case, maybe you deploy a container, for example. So when the container starts up, the application and the data protection API module will create an encryption key for us. And that one is stored in a local path on a local machine. So I can actually go to that path on my computer. I can go to that path. And inside it, there's a key. And this is just a plain XML file. So I can just open it up. And this is the content of my key. So there's something like, when it was created, the expire date and similar. There is details about how it's protected. But here is my kind of data protection key that is used to encrypt the data that is stored in my cookie. And for example, if I were to delete this key
Quick
file.
question, if I may.
Yes.
With that encryption right there in that XML file, is it by default? So I assume if you do your custom, you're responsible for this. But by default, if that encryption key expires, the default framework that is in place would recreate a new key and store it there. Would that be correct?
Yes. So every 90 days, it tries to rotate the keys, creating a new key for you. And the old key will still be in the key in that XML file, but it will add more keys to that file. So by automation and by default, every 90 days, the data protection API will create add a new key to this XML file.
So be careful how much custom code you do, because you'll take on that responsibility as well.
Well, it's all actually handled by the protection API by itself. So you don't need to do that much you don't need to worry about it that much. A little bit, but not that much. I will come to that part in a bit. So if I delete the key on my disk, and if I restart my application, we will see that it will create a new key for me. So even though if I delete it, a new one will be recreated each time I start up my application. So that's, by default, is very helpful, very friendly. It tries to be a really good, citizen here, trying to help me as a developer to get my thing up and running. But we have some issues here. So in our case, if we have, for example, 2 instances and 2 containers, that means that we have 2 different keys involved here. So that means that cookies signed by this key will be rejected here in the second one. And that is our problem in my example, that we have 2 different keys, but still we only have 1 key here. So why do we have 2 keys? And that is, we need to address this problem because we only have 1 key, both are using the same key, but still those cookies are rejected. And also second problem is that if you, for example, deploy version 1, you create an encryption key, you issue version 1 cookies, and then you deploy version 2, and that one creates a new key. And then if you send in version 1 cookies, then those will be rejected as well. So that is also a problem, annoying thing. So that means that, in production, we need to store this key somewhere else. And, in a database or, in Azure Key Vault or blob storage or Redis or on disk somewhere as a more persistent, because we do not want to recreate the key each time we deploy, because then all outstanding cookies will be rejected. So it's a pretty bad user experience. So in our case, just to kind of simulate, we can set, we can configure the data protection in our application to store it in a different path, just to kind of to demonstrate. So we will update both instances and set where to persist the key to. And so that means that we go back to my application, and I will address the questions in a bit. I will just copy that one. So I will go to the first instance. I will just set the path to cconf keys, conf for conference, and I do the same thing for instance 2. So basically, if I go to disk and to the C drive conf, it's empty right now. And if I start my application, it will create this follow keys for me with a key inside. So both now, will use this path, both will use this key. And if I were to try to use, go to my application and I do sign into one of them, it will not really actually work, because, you only need the one, but the other one will still reject it. So Matt had a question, does one key encrypt all the cookies, or is there one key per cookie? Well, I will come to that in a bit. But so far we have one key, and we see the key in here, and both my instances uses this key, so that's good. But it still does not work. So we need to talk about another thing. We need to talk about the purpose. What? The purpose? What's that? So the purpose is a way to create isolation, to create a more secure setup. So we have our master key, and that key is the one we have in our XML file. It's the same thing. So we have a master key. Both my instances uses it, but we don't use this one directly. Instead, we use a key derivation function and a purpose to create, derived keys. And those are the ones we use to encrypt information. So you can have many purposes, and that creates isolation. So data encrypted for the sales system can't be decrypted by the order system and vice versa. So it's a way to create new keys, to create isolation, and you can have different keys, all based on the same master key, but they are kind of independent keys, different keys each one, and that is a thing that we need to be aware of. So that means that, okay, so let's try that. A challenge here. So we saw the unprotected demo as I showed you before. So if I try to I go to application 1, I encrypt something with a purpose string. I go to application 2 with the same purpose string, and I try to decrypt it, but it does not work. So let's just kind of demonstrate. So if I go to application 1, I protect, n.tulsa like that. I have a purpose string, encrypt it. I can also decrypt it here in instance 1. It works fine. If I now copy this encrypted string to the second instance, we have the same purpose, we have the same key, it fails. We get an invalid payload. So why does it not work? I mean, the purpose is the same, with the same key, but it still does not work. This is really kind of weird. Let's try to address this. So there's a secret. So there's also, ASP.NET Core adds a path to each application as one of the purposes. So you can have you can have an array of purposes. So for example, if you use a session middleware, the name of the middleware, session middleware, is used, and the path. If you use the cookie handler, it's actually 4 different purposes. There's a path to the application, there's a name of the handler, the middleware, the name of the scheme, and the version of the handler. And in my example, when I use the protect and protect demo, it also uses the path and my customer data v1. And we can actually see that if we go to the Aspire console, we can actually see in the logs that, it performing, and let me see if we can just like that, or just like that maybe. So we see that it, tries to perform unprotected operation to a key. There's the key in an XML file with purposes, and you have a path to, the application and customer data v1. So that means that because both applications are on different paths, that means that the data can't be shared across them because the path is data protection 1 and 2. So that's the key here. So we need to set, let's kind of replace this path, the use of a path, with my own kind of application name instead, so that cookies within my application, even if I have multiple instances of the same application name, they can be shared, this information. So I can actually go to my program class. I can add this set application name. So we basically replace the path, the use of the path, because that is the default application name if we don't set it. So now if we have set this application name, I can open both instances. I can go to, the first one. I can encrypt some information. I can go to the second one. I can decrypt it here, and it works. And also, if I try to go to the the load balancer endpoint, and I do log into one, I'm actually, if I go back here, actually logged into both now. So now it works. The cookies are accepted by both instances because I set the path to be the same. So getting ASP.NET Core into production has its challenges, getting the data protection configured, set up correctly, and so there's a lot of pitfalls. The presentation can be found on my GitHub here. And if you want to read more about me and my writings and or training, you can go to my blog or my company website. And question time. Do you have any questions? Or is it all totally clear by my excellent explanations? No, questions.
Oh, there was a lot of excellent explanations.
Yes, thanks.
Absolutely. Yeah, this made a lot of sense. And it makes, I was thinking about this too, is that when you're storing it on the file that, when you're setting a directory, you could, if you're hosting this on like an Azure app service, you can do a file mount that's to an Azure file storage and have that be that storage location. So it doesn't have to be a mounted, well, it kind of acts like a mounted drive, but it doesn't have to be IIS. It doesn't have to be a Windows box. It could be
No, it can
serverless.
be anywhere.
Yeah.
And also, if you want to read more about, how you can do it yourself, if you want to do to store in some custom location, then I actually do have a few blog posts about the data protection API, and one about how you could write your own custom, implementation to store your key ring in Azure Key Vault. There's also a debugging tool I kind of published, allowing you to create keys or revoke keys. So there's actually a built-in function that you can actually manually trigger a key rotation, or if you want to revoke all existing keys and create a new one, that can also be done. So this tool actually displays some more details about the keys and so you can learn about how the data protection key and the key ring actually works. So I'll paste the link to that one in the chat.
Awesome. And I see Maxim has a question.
Yeah. Can you hear me?
Yes.
Great. So, Tore, a couple questions. So we have multiple methods in a cookie middleware, right? Like sign in, sign out, and we have forbid, right?
Yes.
In which case should we use forbid as a cancellation of unsuccessful? Yeah, right.
So forbid is about when you go to your application, you are authenticated, you have a user, but you are not allowed in because you don't have the right credentials, you don't have the right claims, you're not allowed in. Then you call the forbid, and then you make a redirect to your access denied page.
Will it redirect automatically?
No, I mean you can when you call forbid, it will do a redirect to that page, and in the cookie configuration that they used, you can actually define this access denied path like this.
Access denied path. Am I right? We can say access denied path equals login path. So it's like we get login screen again and again.
But maybe that can make that could make a loop, that is hard to understand if you don't know why you're logged out or you can't access. Why do you end up on login each time? That can be a bit confusing as well from a user experience point of view, I think.
Yeah. Another question about redirect. So when we use sign in, sign out, or challenge, let's say sign in, right? We can pass schema and the principal, and then we can do a manual local redirect, or we can provide redirect URL inside authentication properties. Which is preferable? Because right here in your code, I can see local redirect and I can see redirect URI inside authentication properties.
You can actually do it both ways.
Yeah,
so I
but
could
which
actually
one do you
have
like more?
so you could actually, if you want to, you could actually go to the login here, and if you don't return anything at all, if you remove this one, you will actually go to this one. So we can let's like see if it works. Like that. And if you try to log in now, I need to just shut down the other application.
So it will be handled by cookies middleware probably.
Yeah. So let's say I think I made some typo here. Login path. I need to read. Okay, and this is because I do expect to return something. So now let's see what happens. So now if I log in, I will end up on a Tulsa page.
Right.
So basically, if you don't do a redirect down here, it will use this one up here.
Yeah, makes sense. Thank you.
Yeah. Any more questions?
Yeah, there was one that came in. Can you authenticate against Windows and fall back to username and password?
You could, I mean, you could in theory add the Windows authentication handler as well, and then you have a cookie as well, and yes, you can have multiple authentication handlers, but it's a bit more tricky to get that to work properly. But you can do it, of course, because all it's all about. If we just kind of get the slides up again, it's all about somehow you need to have someone that either uses a cookie or the Windows authentication identity, and then you have and someone needs to kind of create this claims principal object, and you can add the Windows identity handler as well to the authentication middleware. So a question: if someone permission changes, you need to sign in the user again, because the data inside the cookie does not change until you sign in again or sign out, sign in the user. There's no way to refresh it in a good way, unless you maybe use the approach of the cookie store that I mentioned before, that do have in this blog post. That one, you could, in theory, allow the user to refresh the information that you store here, but that is a bit more advanced use case, I would say. And also using the session store has some other benefits, and that is that you can actually do this kind of experience, that you can actually query this database and, for example, view, I get a list of all my user sessions, for example, and you could sign out individual sessions, for example. And you can also do a emergency sign out of everybody. For example, if you're hacked, you can actually just delete the database and then everybody is signed out from the application. So that's also, some benefits by using this backend session store. Does that make sense?
Yeah, absolutely. And a lot of great comments in here. And Eric is asking about, how would this work with API authentication? And I believe that would be a little bit different.
Yes, it's usually you use Jota tokens for APIs, and you don't typically use cookies. It all depends on your setup, but it's a bit beyond the scope of today's session to talk about the API protection. That's another kind of talk. And also, okay, so to Matt's question, if you use this kind of session store, you have actually multiple expiry times. You have one expiry of a cookie, maybe the cookie only is kind of valid for 2 weeks. So that's one kind of timeout that you can set and control. And then you have the data inside the authentication ticket, and that is actually stored in the session store. But you typically don't change that after each login or after each use. That is typically pretty fixed. But you could, in theory, change that manually if you like. That could work, I think. Any more questions?
All right. I think, yeah, we had a lot of questions come in that you have already covered, and a lot of great comments coming in. And yeah, demystified a lot. Yes, that was a very good explanation of things. And this is one of those kind of videos where I know for myself, I'll be rewatching it because it's going to take a little bit to kind of chew on all the little details and then go get your hands on it and go play. So I'm sure your blog is going to be read a lot. So it's, your details there are much appreciated as well.
Yeah. So, go to my blog if you have any questions, and feel free to email me and connect with me on LinkedIn. And the presentation and the code I've been using is on my GitHub link here.
Yeah, and Eric pointed out something too. I want to make mention. Thank you very much for speaking. because it's now 3 a.m. in
Yes,
Sweden.
it is.
And so for everybody over in the Europe area, thank you so much for being here tonight. And thank you, Tor, for speaking. This is great. Really appreciate this. And staying up late for us,
Yes.
for us mere mortals in the US, we greatly appreciate it. So thank you very much.
Yes. Okay, Van. So have a nice day and good night. And over to you, Sean.
All right. Thank you all for coming out tonight. I'm going to go ahead and stop the recording, but you're more than welcome to hang out.